To prove, we want to make two columns labeling one of them statements and the other one reasons. Then we want to use what's on the right and left side of the equal sign as our first and last statement. Normally you use the uglier of the two sides as your first statement, but anytime we have the sign of 2x or 3x or so forth, we're going to use the sum difference property to expand. So I started with the sign of 3x as my given. We're going to rewrite 3x as 2x plus x. This is going to allow us to apply the sum difference property to expand. The sign of 2x plus x is like the sign of a plus b. Our a is 2x and our b is x. So I applied the formula and got the sine of 2x cosine x plus the sine of x cosine 2x. Looking at the third statement, I noticed the sine of 2x and the cosine of 2x. We could use a double angle formula here. I'm going to start with the double angle formula for sine of 2x. The reason I'm starting with this one is we only have one option for the sine of 2x. So I'm going to replace the sine of 2x with 2 sine x cosine x. I will want to eventually replace the cosine of 2x using the double angle formula for cosine of 2x. However, the double angle formula for the cosine of 2x gives us three options. One of the options has all sine in it, the other all cosine, and the third a mix of sine and cosine. Keeping an eye on what we're heading towards is always a good idea to help us select the best option. What I'm noticing right now is what we're heading towards has a sine of x. And I look up above at the fourth statement and see that sine of x is in common to both of the terms. So I'm going to factor out the sine of x so that we now have one of the pieces that is in our final statement. Factoring out the sine of x that is in both terms, we get this. I do want to replace the cosine of 2x, and if I look at what we're heading towards, I see that we're going to turn this into 4 cosine squared x minus 1. I can tell that I should use the substitution for cosine of 2x that contains all cosine since I'm heading towards all cosine. Selecting the double angle property for cosine of 2x, 2 cosine squared x minus 1, I substitute cosine of 2x with the 2 cosine squared x minus 1. All I have left is to combine like terms. 2 cosine squared x plus another 2 cosine squared x is 4 cosine squared x, and we still have minus 1. In this particular problem, I did not work backwards one step from the final statement. However, writing the final statement did prove to be important as I had to continue looking at what I was heading towards to figure out which substitutions were the best idea. This completes this proof.